Hello, this is the presentation for the ET302 Comparator Lab. And what I have here is a multi-sim diagram, a circuit, of a comparator using a standard 741 op amp. And since we have no feedback on this device, we're going to use it as a comparator. And we have 6 volts fixed going into the non-inverting, and we have a variable voltage going into the non-inverting. And what I have here is a potentiometer set at 12 volts on one side and 0. So this is actually a variable voltage supply. And I could change it by using key A. And what we're going to do now is I'm going to run multi-sim and we'll see how this circuit reacts. Here we have our working multi-sim circuit. And the rule is whichever one is larger, it's going to drive it to that rail. Here we have a fixed 6 volts, and I use my variable voltage pot here. And right now we have 6.6 on our non-inverting side, which is greater than 6, so it should drive it to the positive rail, which it does. 11 volts is a fraction of the 12, which is a little bit less than the maximum, minus 12 volts. Okay, so let me go ahead and see if I could drive this lower than the 6 volts, and it should go to the negative rail, which it does. So 6 volts is greater than 5.4 into the minus, so we're going to drive it to the minus rail. Here's our second multi-sim circuit. This time we've added a 6 volts fixed into the non-inverting. And here again we have our variable voltage coming from our potentiometer. So let's take a look at the working circuit. Here we have our second working multi-sim circuit. We have a fixed at 6 into our non-inverting, and we have 4.2 volts going into our inverting. Okay, and 6 is greater than 4.2, so we should drive this to the positive rail, and we did. 11.8 is close to the 12 volt power supply, which is correct. So let's go ahead and increase that and see if we could get it to switch when we get past 6. And we did. So 6.6 is greater than 6 into the minus negative rail, or negative input, and it drove it to the negative rail. Here we have another multi-sim circuit, this one based on a 339, which is a actual comparator designed to be a comparator, and it minus is actually going to a ground, and plus is 12 VCC. Okay, this one is an open collector device, so we have to have a pull-up resistor. So we're using this 1K and the 12 volts as a pull-up. And if this one goes to ground, if it's a low, this LED should turn on. Over here is a voltage divider, and it's even. So it's 10 divided by 10 plus 10, multiplied by 12, which should be 6 volts. It divides the voltage in half. And here we have our meter, and again we have our variable voltage. So this one is going to go either to ground or open. So let's see how it operates. Here's our circuit based on the 339. Here we have 5.4 volts, which is less than our voltage divider providing a 6, which means it should go to the negative rail. The negative rail on this device is ground. We're providing a ground for this LED, so it should light, and it is. Okay, so let's go above 6, and it should open up and allow it to turn off. And it did. 6.6 is greater than 6, so we go to the positive rail, which closes this off and doesn't provide a ground path, and it's off. Here we have another multi-sim circuit based on the 339, and what we're doing with this is we're going to make a nightlight simulation. So this guy here is a photosensor of some type. Simulation, we don't have photosensors in multi-sim, but what it's going to show is I could use these comparators to turn things on. So this guy could be a light sensor, could be a temperature sensor, could be a level sensor that shows that your pet food's empty. So a lot of things this guy would be good for. So let's go ahead and see how he operates. Here's another circuit that we just talked about. This is our nightlight sensor. This is a phototransistor, and when it has a little bit of light, it's a high resistance. So right now it's dark and the light is on. So once it gets lighter, we should eventually turn that light off. So let's try it out. And there at 70% our light turns off. So we keep going down, same thing. So alright, so it's getting dark again, so let's raise our resistance of our photosensor, and it's dark at 75%. Works good. Here's a circuit we do in ET322 is a kind of an extra deal here. What we've done is we've stacked a bunch of resistors, a voltage divider, and we have a variable voltage going in, and as the voltage changes, these LEDs should turn on. So this would be something, let's say a knob that for fans. So once we go to the different positions on that knob, the fan speed would increase or decrease depending on how we set it up. So here we have a variable voltage, and our comparators are going to react based on that voltage. Here's our comparator stack circuit, and here's our voltage meter, and our potentiometer is turned to almost zero. All LEDs are off, so let's start claiming. Okay, here's our first LED, 2 volts, which is reasonable since this here is at 2 volts. Let's go to the next one. And it is on. And we're at 4 volts, 2 and 2 is 4, so that LED is on. Let's keep going. There's 6 volts. 1, 2, 3 times 2, 6. So our LED's on. So let's keep going. And 8 volts. Let's go a little more. There we go. And 1, 2, 3, 4. So 8 volts. And we have all our LEDs on.